Uniform circular motion. When we deal with uniform circular motion, we're dealing with objects moving in a circular path, and we say that they undergo rotational motion. We're going to talk about angular velocity calculations today. And when we talk about angular velocity, it's defined as the angular displacement per unit time. The units for angular velocity are radians per second. So the equation we want to use is angular velocity equals the angular displacement divided by the time. So we'll look at a practice problem involving velocities. If a whistle tied to a string takes 10 seconds to make 15 revolutions, what is the angular velocity? Well, like problems we've done in the past, we're going to want to write down our variables, write down the equation for solving angular velocity, plug in the variables, and then solve our problem. So for this particular problem, we're trying to find our angular velocity. When we talk about the angle of displacement, we're saying that the whistle went around 15 revolutions. Well, we know that one revolution is 360 degrees. So to calculate 15 revolutions, we would take 15 times 360. So the total angular displacement is 5,400 degrees, but we need that value in radians. So we'll multiply by pi and divide by 180, and that'll give us the angular displacement in radians, which equals 94.2 radians. And we're given the time it takes to travel that distance as 10 seconds. So now we'll talk about our equation. So the angular velocity is going to equal the angular displacement divided by the time. And then we'll substitute in our numbers. So the angular velocity will equal 94.2 radians divided by 10 seconds. So our angular velocity in this problem is 9.42 radians per second. And that's considered to be our angular velocity.